All right, so now that we have a working understanding of sort of what NumPy arrays are and some of the things we can do with NumPy and how the package sort of allows us to do some neat stuff, and we can actually just create the arrays as we need them, let's talk about the arrays themselves and what we can actually do. I've mentioned multiple times that NumPy is an extremely powerful and very, very efficient and very, very useful package in data analysis. And why is that? Okay, so we're going to talk about just some of the architectural elements and the structure of some of these arrays and why it's useful. Okay, so in this particular video, we're going to talk about attributes of arrays. So size, shape, memory consumption, data attributes. We're going to talk about indexing. So again, indexing of arrays. Just like in a grocery list, you start at 0, 1, 2, 3, 4, 5. In a multidimensional list, you can index it sort of like a row column X or Y coordinate sort of a way. And again, in future classes, we'll dive deeper into that, but for now, we'll just kind of touch on it. We'll talk about slicing arrays. We may touch a little bit on reshaping, joining, and splitting, but I'm not going to go too terribly deep into that as it's a bit advanced for 101, but we will definitely get to attributes, indexing, and slicing, okay? So when we talk about the attributes of NumPy arrays, okay, we need to sort of talk about what we have here, okay? So here they're going to sort of define some stuff. We'll do this in our code. And we'll actually create some different, they're creating random integer 10, so they got size of 6. They got 3 fourths, 3 columns, 3 rows. They got 3, 4, 5, means 3 columns, or 3 rows, 3 columns, and also 3 depth. Okay, so that's going to create a 3-dimensional array. Okay, so having those is going to be useful. And here is where we actually talk about what the attributes of each one of these arrays are. Okay, so our first thing that we have is called indim. Okay, that's the number of dimensions, indim. Okay, so if I create a NumPy array, and it is a single dimensional array, indim is going to give me 1. If I create an indim, or if I created a NumPy array and call the indim on it, it's going to give me like a 2-dimensional array, like an Excel spreadsheet. It's going to give me 2. If I want a 3-dimensional, 3, so on and so forth. Okay, so indim just stands for number of dimensions. Is this a 1-dimensional, 2-dimensional, or 3-dimensional? Okay, shape is sort of the size of each dimension. How many rows? If we're thinking just in a 2-dimensional row or 2-dimensional array, how many rows? How many columns? If we're thinking 3-dimensionally, we have, you know, what is our X, what is our Y, and then what is our Z. Okay, so it's going to give us sort of the dimensionality of each of those. Okay, so you would have sort of rows, columns, depth is what you would have in terms of shape, and that gives you how many you have. Okay, then you have the size, which again is just the total size of the array. How many things do you have inside of that array? And then you have dtype, which is going to be the data type. So dtype is just a sort of a universal identifier in NumPy that sort of tells you what's the data type of the particular array. So you can see here, you know, they do x3dim, x3.indim is going to give you 3, x3.shape is going to give you 3, 4, 5, x3 size is going to go, x3.size is going to give you 60, and then x3.dtype is going to give you a 64-bit integer because that's the way they created them. Okay, so those are sort of the attributes. You have the ndim, or number of dimensions, the shape, which is the size of each dimension, the size, which is just the total size of the array, how many values you have, and then the dtype. Okay? We also have this idea of indexing, okay? So going back to when we were talking about lists, we remember that lists have indexes, okay? And list essentially basically parrots memory in your computer. Every memory slot in your computer has an address, and something can be stored at that address. Okay, so when we talk about lists, lists start at an address, and then they have offsets added to them. Okay, so the beginning of every list is the address plus 0. The next element is the address plus 1. The next element is an address plus 2. And then the address plus 3, the address plus 4, the address plus 5. Okay, and then you could dereference the value in memory and get it. Okay, so that is what indexing means. It's just, hey, here is the list. Now offset up into the memory locations and find me the thing that I need. You can also just say it's the ith, the index value. Okay, so in a list, a grocery list, where I have, you know, bread, milk, butter. Bread will be at the 0th index. Milk will be at the 1th index. Butter will be at the 2th index. Okay, I know it sounds weird, but we're in computer science, and sometimes it can be kind of funky. But in computer science, we always count from 0. Okay, so that's array indexing. Okay, so we have created these two arrays up here, or these three arrays. So again, just to let you look at that, we have x1, which is a one-dimensional array, x2 is a two-dimensional array, and x3 is a three-dimensional array. Okay, so here we have x1. Okay, it's just 503379, just a single array. Okay, we can index that directly just like we index lists in Python. Okay, so the name is x1. I can use the square brackets and then grab some value out of it. Okay, so at the 0th index, you're going to get 5. If this was 2, you would go 0, 1, 2, so I'd get a 3. If this was 4, I would go 0, 1, 2, 3, 4, so I would get a 7. Okay, so that's just a basics of indexing. It's exactly the same in NumPy as it is in a Python list. Now, just like Python lists, you can also negative index. Okay, so all this is going to do is it's going to get the size of this particular array and then subtract 1 from the highest, subtract 1 from that number, essentially. Okay, so 1, 2, 3, 4, 5, 6, minus 1 is 5. Okay, so 6, so get the size, which is 6, minus 1 is 5. 0, 1, 2, 3, 4, 5, boom, I have 9, okay? So this is essentially size minus 1, but we reference it as negative 1. Okay, so if you want to count backwards from your highest index to your lowest, you can just use negative numbers, okay? So that's exactly the same as a Python list. Okay, so in a multidimensional array, I'm sure you're thinking, okay, I understand indexing in say a single dimensional list. That's a piece of cake. Start at 0, count up. No big deal. I can do negative if I want to, which is just get the size of it and subtract 1 or 2 or 3. No big deal. It's a piece of cake. So what about a multi-dimensional array? Okay, and that's a good question, okay, because it can be a little bit more complicated than you think, okay? So when we think of this multi-dimensional array, I want to point out a few attributes here. You'll see this and this. Okay, now those seem like just things that are hanging out there, but what this is saying is this list, and this list are values in this list. Okay, so this is called x2. If I were to get x2, the 0th element in x2, well, this is x2. The 0th element would be this list. The 1th element would be this list. And the 2 element would be this list. Okay, so x2 0 would just print out 3524. x2 1 would print out 7688. And then x2 2 would print out 1677. Okay, so what if we want to get a single element? We don't want to get the whole list. Well, I can then dereference that list, right? Okay, because I got a list out of it. Okay, so I can get the 0th element out of x2, and then out of that, I can get the 0th element, which is 3. Okay, so let's say it's 1, 1. I would get the 1th element out of x2, and then 0, the 1 element out of that new list. Okay, let's say it's 2, 3. Okay, so I would get the 2 element at 0, 1, 2, the 3 index. Okay, so that's the way that works. So 0, 0, and you can sort of think of it this way. 0, 0, 0, 1, 0, 2, 0, 3, 1, 0, 1, 1, 1, 2, 1, 3, 2, 0, 2, 1, 2, 2, 2, 3. Okay, that's the way that you would sort of think about these coordinates. This one is going to say, hey, get me row number, bleh, okay? Get me row 0. Get me row 1. Get me row 2. This one says, get me column, bleh, right? Okay? So get me row 0, which is this one, column 0, which is this one, because we're computer scientists and we start at 0. Okay? So you can also wrap it around just exactly like previously. Okay, so get me row 2, so 0, 1, 2, so it'd be this. And then take the size of it, which is 1, 2, 3, 4, and subtract 1, so that would be 3. So it would be 2, 0, 1, 2, 3, and then I would get 7. Okay, and as you can see, you have 7 there. Okay, so pause the video, think about that a little bit. It's very, very important when we move into Cyber 150. For any of you that are going to take it, we'll dive way deeper into multidimensionality, where we find out that we have lists upon lists upon lists upon lists upon lists, and how it's very important to be able to conceptualize that correctly. Okay. Now, again, using this index notation, we can actually change values. So right here, if I did a print x200, that would print out 3. Is essentially what that would do. Okay, so I can sort of dereference it that way and print the values. I can also set the values in the same way. Okay, what you want to do is you want to think of the data flowing from this side of the equal sign to this side of the equal sign. Okay, so 12 is going to flow into, going from right to left. 12 is going to flow into x2, give me row 0, column 0, okay? 12 goes into row 0, column 0. Okay, so what happened is row 0, column 0 is now 12, okay? Now, again, you got to remember they have a fixed type. So this is an integer type, so the D type's int, okay? If you try to do this, what you're going to get is a truncation, is what it's called. A truncation is not a round, and I want to sort of beat that into the ground a little bit. Truncation is just simply dropping 0.14159, okay? So if that was 3.9, the truncation would still leave it as a 3. It would just drop the 0.9 and leave it as a 3. It's not rounding, it is truncating, okay? A 3.9 would round to a 4 mathematically, but truncating would just cut it off. Just cut off 3.9 and it would stay as a 3, okay? So again, make sure that you remember that if you're going to try to put pi, 3.14159, into an integer array, it's only going to come out as 3. Okay, and that's an important thing to understand. All right, so a lot of times, and we talked about this in strings, where sometimes we like to get substrings, and a string is nothing more than an array of characters, okay? So when we talk about this idea of array slicing, all we're talking about is creating subarrays, okay? So essentially what we can do, we can actually access subarrays using sort of the slice notation, which is marked by the colon or the colon character, okay? So essentially you can do this. You would get your array, your start point, your stop point, and your step point, and then you would create a subarray, okay? So again, this is a lot like range, okay? So if any of these are unspecified, they default to 0, and stop is the size of the dimension, and step is 1. Okay, so you can sort of do what you need to in sort of creating these subarrays if you don't define them. You just put colon, put the colon in and call it a day. Okay, so here's an example. We create an array, cool. So what we have here, just like on our strings, since I didn't define anything here, I'm starting at 0. Okay, and then I'm going to go to 5. So I'm going to get the first 5 elements, okay? First 5 elements, okay? Now notice I don't have a second colon, so it assumes that it's going to be step by 1, okay? So 0 to 5, 0, 1, 2, 3, 4, that is the first 5 elements, okay? Now we can create a start, so this is sort of defining a stop. We can create a start, okay? So we're going to start at 5, index 5, so 0, 1, 2, 3, 4, 5, start at 5 and go to the end. Okay, so again, I didn't find the end, so it's just going to go to the size of the array. So 5, 6, 7, 8, 9 is what we're going to get. Okay, now we have a start and a stop. So we're going to start at index 4, end at index 7. Okay, 0, 1, 2, 3, 4. So we start at 4 and we go to index 7, non-inclusive. So remember that, it's non-inclusive just like in strings. 4, 5, 6 is what we end up getting. Okay, this one right here is going to get every other element because it's assuming you're starting at 0, ending at the end of the array, and jumping by 2. So 0, 2, 4, 6, 8. Okay, you can also start at 1 and jump every other, 1, 3, 5, 7, 9, so on and so forth. You could start at 2 and jump every other, 3, jump every other, however you want to. Okay, so I would encourage you to definitely fiddle around with that a little bit to create those subarrays. Okay, because a lot of times data analysis is a lot about pruning the data set and getting the values out that you want. Okay, now you can also have sort of a confusing boundary case where the step is negative. Okay, so essentially all you're doing here is you're just swapping start and stop. This is interesting. It's cool. I would suggest you don't get in the habit of using it. okay? It just means you can reverse an array if you really, really, really want to, but there are other ways to reverse it that are just as convenient, okay? So all you're doing is reversing the array. So like a -1, you're starting and going to the end, and then you reverse it. So now we're down to 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, okay? This one starts at 5, and then it reverses every other from index 5, okay? So it's just reversing the index. Again, it can be useful, but don't let it confuse you too much because it is different than sort of the other list uses, okay? You can also create sort of multi-dimensional subarrays. It's basically just using this notation right here, using this notation and separating it by commas is all you're sort of doing, okay? So here's x2, gives us a two-dimensional array. What we're saying here is in array, so in row, in this particular row, okay, we'll start at 0, go to 2, then we are going to, in these columns, from 0 to 3. So we're going to get row 0, row 1, row 2, and we're going to get columns 0, 1, 2, 3. Okay? So you can see I got 2 rows, 1, 2. And I got 3 columns, 0, 1, 2. Okay? So it created a sub-array of that main one. Okay? This one is every other. You're going to get 3 rows, and then you're going to get every other value. And then that one is going to go ahead and reverse. Okay, so you can actually sort of reverse the size of your, or the shape of your index. Okay, which is pretty cool. But just remember, it's just using these in commas. All right, so again, you know, a lot of times you just need to access a single row or single column, which I kind of mentioned earlier. You can actually just use the colon here to say, hey, get the first column of x2. Okay, so hey, get all the rows. So start to stop, you're going to go from 0 to size and only get column 0. Okay, so that's very, very useful to just get the column. If you just want the row, you can do this. You actually don't even need to add this kind of stuff. It'll just give it to you. But if you want to add consistency or practice, basically this is going to get you row 0. And this is going to go from 0 to size on column. Okay, so that's just going to get you the first row. This will get you the first column. Okay, and then of course you can also do this. This is what I explained to you earlier, because essentially what you're doing is you're saying get the 0th element out of x2, and the 0th element of x2 is 12, 5, 2, 4. Okay, so you can see 12, 5, 2, 4. So this is just a little bit more complicated. Just depends on what your particular preference is on those. Okay, so we're gonna kind of skip the no copy views because it's a little bit more advanced than what we want to talk about right now. We can also arrange, I encourage you to look through this if you want to. If you have a little bit of passion for data analysis, it's a little bit advanced for 101, but if you want to go ahead and reshape it, you're more than welcome to explore those kinds of things as well. So concatenation, all concatenation means is combining arrays. This can be very, very useful. You use the np.concatenate function. So I would create an array, and I would create another array. I have x and y, so I have an array of 1, 2, 3, and 3, 2, 1, and I can actually use the np concatenate here with x and y to combine them together, okay? And you can do that with multiple different arrays if you would like to, okay? So that's the way that you can concatenate arrays very, very quickly. All right, so that is the end of this particular video. We're going to jump over, do some coding in the next video, and begin to sort of tie this lecture up.